Hello everyone. In this video we'll talk about the fundamental theorem of calculus. So if you got a continuous function f on the closed interval ab and you define a new function uppercase f of x to be the integral from a to x where x is in between a and b for a function f of t dt, f of x is going to be continuous on the closed interval ab and differentiable over an open interval ab. Then it says the derivative is just going to equal to the function evaluated at x. So really all that happens is the upper limit, which is x, gets plugged in. Now let's look at some examples here. By using the fundamental theorem of calculus, find the derivative dy over dx for the given function. So what we are going to do here, because we are using the fundamental theorem of calculus, the derivative will be dy over dx will be equal to d over dx for the integration from a to x t cubed plus 1 dt, and by plugging the upper limit here, the final answer will be x cubed plus 1. That's basically everything. Let's try this one here. So from x to 5, now we're supposed to have x here, so the inverse will be negative 5 to x 3t sine t dt. And when you want to find the dy over dx, d over dx, negative the integration, 5 to x, dt, and that's going to be equal to the negative, and plug x in here, negative 3x sine x. Now what about this question here? I don't have x, I have x squared. So we are going to use the substitution method. So I'm going to say u equal x squared, du over dx will be equal to x. So I'm going to go here and say, okay, dy over dx equal d over dx integration from 1 to u cosine t dt multiplied by the derivative of u, which is 2x. So the answer will be, now here for this one we're going to plug u the inside, so it's going to be cosine u multiplied 2x. I should have x squared, so cosine x squared 2x, and we should write it 2x cosine x squared. Let's try this one here. Again, we need to take the inverse, so I'm going to switch between these two, and that's going to be y equal negative 4 1 plus 3x squared 1 over 2 plus t dt. Now I need to find dy over dx, which is equal d over du and I'm going to use the substitution method, which u will be equal to 1 plus 3x squared du over dx equals 6x, negative 4 to u 1 over 2 plus t dt, all of this multiplied by du over dx, which is 6x. Now I'm going to plug u inside, so that's going to be equal to negative 1 over 2 plus u multiply 6x, and we need to go back and write u as 1 plus 3x squared, So that's going to be negative 6x over 2 plus 1 plus 3x squared, which is going to be equal to negative 6x over 3 plus 3x squared. And of course, you can simplify by taking 3 as a common factor. That's going to be 3 multiply negative 2x over 3, 1 plus x squared. Cross out these two. Final answer is negative 2x over 1 plus x squared. For this question, we need to find the derivative of the integration cosine t dt from 0 to square root of x. Well, in this case, we are going to use the fundamental theorem of calculus. And what we are going to do basically is finding the derivative of square root of x. So I'm going to say, let u be a square root of x. Then du over dx will be 1 over 2 square root of x. So what I'm going to do will be basically the d over du, the integration from 0 to u, cosine t dt, and all of this will be multiplied by the derivative 1 over 2 square root of x. Now, based on the fundamental theorem of calculus, I'm going to put u here down. So that's going to be cosine u multiplied 1 over 2 square root of x. Now basically I'm going to return u into x, and that's going to be equal to cosine, instead of u, square root of x over 2 square root of x. Now this one here, d over d theta, integration from 0 to tangent theta secant square y dy. We need to find the derivative d over d theta by using, of course, the fundamental theorem of calculus. So I'm going to say u equal tangent theta, du over d theta will be equal secant square theta. So now this is going to be d over du 0 to u secant square u dy, all of this multiplied the dy over d theta, which is secant squared theta. Now here I will plug u inside, so that's going to be secant square u multiply secant square theta. Instead of u, I'm going to use tangent theta, so that's going to be secant square tangent theta multiply secant square theta. That's everything about the fundamental theorem of calculus. Please let me know if you have any questions, and see you in the next video. Bye bye.